Hello, everybody, and welcome to the TeacherCast Educational Broadcasting Network, your home for professional development. My name is Jeff Bradbury, and thank you so much for joining us today. We have a great show for you. Today, we're talking all about STEM education and some of the great things that you can do. We have a great company on named Tynker, and we're going to be talking to Dan Rezac from Tynker to talk all about STEM education and what you guys can be doing in your classrooms. We, of course, want to hear from you and all the great things that are happening in your neck of the woods. You can find us on Twitter at TeacherCast. Leave us a voice message over at teachercast.net/voicemail. Email us at feedback@teachercast.net. And, of course, subscribe to this and all of our shows over on teachercast.net/audio and teachercast.net/video. And one more time, thank you guys for being here. I hope you're having a great time in this part of the school year. My guest today has a great program that I'm happy to share with you guys today. I want to bring on from the Tynker Corporation, Mr. Daniel Rezac. Dan, how are you today? Welcome to TeacherCast.
Very good, man. Thank you very much for having me on today.
Thank you so much. How are you today? You are a former educator, is that correct?
Oh, I would like to say I'm always an educator, yes, so because I'm always learning, always growing, it's all in the way you look at things. But yes, I'm the education community manager at Tynker.
And what is Tynker? I know that I've heard a lot about it. I see you guys all over the place on your social medias. Tell us, what is Tynker?
Yeah, Tynker's a coding platform for kids. Basically start them in kindergarten as young as they can go, all the way to maybe 8th grade, 9th grade. And we are pretty much the #1 platform on Hour of Code. So if you've ever done Hour of Code, you most likely have played a Tynker, one of our Tynker puzzles or one of our interactives there.
I love the Hour of Code. It is certainly one of those resources that I share with all of my teachers as we go through here. Tell us a little bit about what we can expect. The website, of course, is tynker.com, Tynker.com. Is this something that a teacher signs up for, or do they have to have an account? How does the website, how's the program work?
Yeah, absolutely. Well, it's free for anyone. Right now, if you're a teacher and you want to go and start teaching your kids computer science with Tynker, go right now, go to tynker.com/join, and you can upload students. You can kind of see what the dashboard looks like. There's free lessons already. You can go and just and dive in and assign those to your students. And if you've done, like I said, Hour of Code stuff, these will probably be familiar to you. So they'll build on those skills. And those free lessons will vary from your very young students to middle school.
And I understand correctly that there's been more than 60,000 schools that have been working with you guys and enjoying the Tynker products?
Oh, absolutely. Right now, more than 60,000 schools. I believe we hit 50 million students, which is a pretty big number. We're really hitting a nerve right now with schools in with computer science initiatives. There's a couple states right now that are really taking it upon themselves to make computer science mandatory, and Virginia is one of those. Florida is another, and I know that there's more that are talking about it. That see these skills as essential skills for getting a job and being successful in the modern workplace. So.
And as you said, it's becoming more and more common where computer science education is just part of this. Google recently launched a computer science curriculum I believe it's called CS First. Mm-hmm. And of course, we have Hour of Code. Microsoft's getting involved with their computer science curriculum. Is there a difference between STEM and coding and programming? And I know we're talking about being makers. Is this all under one big, huge umbrella? Or should we be looking at this as different courses or different pathways for our students?
Yeah, and I think when you're talking programming and you're talking computer science, there are elements of engineering involved that go beyond just text coding. So there's other scaffolding and structure that goes along with that. So I think when we're talking about coding, we're talking about that task of writing that language of technology, which it can manifest itself in JavaScript and Python and Swift languages, or in universal language of Tynker code, Tynker block coding.
I talked a lot to my teachers who are doing coding and computer science and programming and stuff like that. And they're always asking me, where can I go to learn more? Do I have to go to a faraway camp? Can I learn something in my house? Is this expensive? Tynker has come up with a pretty neat solution here called the Blue Ribbon Educator Program. Dan, can you tell us a little bit about what this is and how we can get involved in it?
Yeah, absolutely. In fact, we just launched the Ribbon Educator Program a couple weeks ago. And so you can go to Tynker.com, and I'll just check this link because I know we just updated it. Tynker.com/Blue Ribbon, and it will take you to an application. And basically what the Blue Ribbons are, the Tynker Blue Ribbon Educator Program, is it's a community. It's a community, and our goal is to train the educator of the future, basically to train that next generation of educators who are ready to take on the task of working with their students to give them those necessary skills. And so, we're going to offer an opportunity for them to get trained by Tynker and coding masters, and then it's an ongoing program. So we we'll connect at conferences. We give them opportunities for presenting at other conferences, and being a part of the greater coding community.
And is this a 1-year community, or is this something that you see that if after you go through the first cohort, you're now in with the program and you get this continued support year after year?
Definitely. Once you're a Blue Ribbon Educator, we expect that our community is just going to continue to grow, and that those people are going to find and educators are going to find such value in the resources that we're giving them, and because we're giving them access to all of our curricula, and some early access to tools and stuff like that arise. And they're going to find that valuable, and they're going to want to share it with their kids, and so yeah, they're it's just going to continue to grow.
And who do you see as the ideal person to apply to this? Is this the computer science teacher, or is this the media center teacher, or could this be just anybody who wants to even get their feet wet into computer science? Who do you see applying for a position like this?
Yeah, good question. I think it's if you're familiar with any of these kind of programs, like ambassador programs, we don't we're not looking at this as an ambassador program per se. We're looking at this as a community. And the thing about computer science, is there's a lot of teachers that I know, and because I've talked with them, that have always wanted to learn these skills, and they also know how important it is for their students to have these skills, but they've always been kind of on the fence about diving in. Maybe they played around with Scratch over the years. Maybe they played a little around with some of these online coding programs and whatnot, like Mozilla's Thimble and some of these other ones. But they've been kind of waiting for the right opportunity, and waiting for a community to invite them in, where they could learn these skills and get a leg up, and then share those skills with their students. So I'm kind of, there's going to be educators that apply for this that are going to have experience with Tynker and Scratch and a lot of these other programs. But we're also looking for those that are just really dedicated to making this important in their teaching practice. So you don't have to be an expert. No previous Tynker experience is required personally. So yeah.
I think a lot of the teachers are looking at computer science these days and saying, well, I'm a 4th grade teacher. That's computer science. We don't go together. I think a lot of teachers aren't quite sure yet how to bring computer science into their already existing 4th grade curriculum. What advice do you give anybody out there who might want to try this, but doesn't quite know how to do explorers and sailors and all those different topics, but bring coding into that?
Yeah, that's a very good question. And I will tell you, I had that same struggle working in a middle school and an elementary school. I've been a tech coach and a tech integrator, tech director, and this maker lab coordinator, and STEM coordinator. And so one of my struggles over the years, even with starting with Scratch, has been, how do I bring this out of my lab situation, or how do I bring this out of just our technology STEM, corridor and bring it into the classroom. And if you're using Scratch, that's really challenging, and any teacher I talk to that has used Scratch, if I say, okay, can you just hand Scratch to a fourth grade classroom teacher and say, integrate and good luck, and they all say no, you couldn't really do that. And with Tynker is much different, because the way that our lessons are scaffolded, the way that our tool is put together, is very kid friendly. But we also have an entire library of STEM connections. We would call them STEM lessons, but I like to use the word core curriculum integration. It's a more friendly word, and it's kind of, I think, driven towards the goal, which is to get these tools into the science class and the social studies class, sorry, and math and English. We want to see kids not just learn coding, but we want them to be able to apply it. And I was honestly, for the last 10 years, I've been looking for something that would make it, that would give me those opportunities as an educator to go up to my social studies teacher and say, hey, our kids have been learning this. Can they apply it in social studies? That's all I want to be able to ask and say. And if you've ever been a tech integrator or a coach or director, that sometimes you get the answer, from your teachers, like, I've got a million things, I've got to hit these standards, I've got to do this. And there's sometimes an expectation that's going to be really hard to do that. And I just found with Tynker that it wasn't, that I was starting to have that conversation with my teachers, and it was starting to go that way, that, oh wait, this isn't as hard as I thought it would be. And so teachers were starting to take our STEM lessons and put them into their practice, not being masters, not being super tech savvy, but still being able to say, hey, I can do this. And I just thought that was remarkably different than anything I've ever seen.
And that's one of those things that I like about the applications like Tynker, like Scratch, like all those hour of code applications, is you don't really have to look at it as the hour of code. You can dive into this and then realize, oh, I'm just teaching linear thinking. I'm just teaching, following directions, all these different coding skills that really are the basis for what we're talking about. I take those, I bring those into kindergarten and say, look, if the kid can make the Star Wars character go up, turn to the left, go up, turn to the right, go up, then we can start to get him to ask questions. And then that's the same kinds of concepts as, how do I go to the bathroom? Well, you stand up, you push your chair in, you go, you open the door, you do your thing. It's just following directions and learning how to do this sequence. One of the things that I love about Tynker is not only are you dedicated to helping students learn, but you have a great blog post, I want to pull it up here, on trying to close the gender gap and helping to not push this on boys, but also on girls. And of course, we're sitting here trying to encourage school districts to help close the gender gap. We just did a show a few weeks ago with Microsoft Education where we were working on their Make What's Next campaign. And
Yep.
and it's really, really nice to see that Tynker is trying to help the world bridge that gender gap.
Oh my God, it's an opportunity that you can't ignore. I have a 12-year-old daughter myself, so I want her to be empowered by the future is now, right now. We are automation, all these things we talk about are happening right now when it comes to, we're losing jobs to automation. In the next 3 years, I think we're going to lose 5 million jobs to automation. In the next 10 years, I think that there's something like 40% of middle management jobs are going to be gone. This is happening now. We can't, we have to empower our students, males and females, to get them and give them these skills, because they're going to get out of 12 years old. She's going to graduate college before I know it. And I want her to be prepared. I want her to be ready and have these STEM skills. It's just she's gonna need it.
And do you see a lot with the school districts that you interact of, STEM, it's science, technology, and engineering, and math. And it seems like so many times school districts say, well, STEM is the science teacher's responsibility. And,
Mm-hmm.
the math teacher kind of gets pulled along with it, or we don't really have an engineering department, but, again, it's the science teacher. what advice do you have for school districts, or what advice are you giving school districts to really take all of those content supervisors, put them in a room and say, no, these kids, this concept is everybody's responsibility, as you said, moving forward towards graduation?
Yeah, absolutely. I mean, I've said a little bit already, but I mean, one of, certainly highlighting the idea that, we need to prepare our kids for this. But I think there's a problem with the word STEM. And I think if you talk to anybody who's, a STEM teacher, they'll tell you the same thing. And that's honestly, from a budget point of view, I look at it from in a kind of this scenario, and you have a STEM teacher, and then you have your math teacher sitting in a, you know, in a room with the principal, and the math teacher says he needs more money for textbooks, and the STEM teacher says he needs to buy some Raspberry Pis. And who is going to get the first dibs if they only have a certain amount of money left?
Right.
Now, of course, it's going to be the math teacher, right? And I think we need to be at a point where we see those two on an equal footing, because they are both, the coding part of things is only going to help improve math scores. It's only going to help improve, all of those scores across the board. Having a student know some of these seeds we're planting with Tynker in the earliest of age, of grades, kindergarten, first grade. We're talking about conditional statements. We're talking about, that's geometry stuff that you don't learn till high school. Having that stuff planted that early is not a bad thing, not at all, right? So I always try to make sure that they see, at least when it comes to coding and Tynker, that we are planting these seeds so early, it's going to have an impact on all of your other domains, so your math, your science, your social studies. And the other thing too is, if you look at it as if you're teaching a language, and this is the thing, and I think the way that Tynker really treats coding, and a way that I totally believe as well. If you look at coding as like what I've asked before in other places, what is the language of technology? And in many ways, coding really is the language of technology at its bare essence. And so if you want to get a student and you want to work with them on the language of technology, you need to start at the earliest of age and teaching them how to code. And that's because if you're going to be fluent in any language, whether it's French, English, or Spanish, or anything like that, you want to start in the very earliest of age. And so if you look at things a little bit differently, think differently. If you look at things that way, you're going to always have a space for coding, and maybe we can do without the word STEM, and we can start talking about just language.
Well, do you see STEM? I mean, we hear this over and over again. It's kind of become cliche, but it's not technology if it was created before you were born, right? Like for my 3-year-olds, iPods is not technology. iPods is just there. The internet is just there. It's not really technology for the kids. We are dealing with kids that have been alive, cable modems, Wi-Fi, all this stuff has been around since before the kids were born. Do you see the day where, as you were saying, we're not calling it STEM, it's just part of education to be bringing in the computer science and the coding and programming and whatnot?
Yeah, well, I think you're seeing a repeat of what we did 25 years or 20 years ago with technology labs, right? So we had technology was very expensive, so we created labs where kids could go down to the lab and they would do a little bit of hop on a computer and do Oregon Trail and maybe do some Microsoft Word and stuff like that. And then we got personal mobile devices, and so we were able to free up the lab. And so that was great. In the last 5-6 years, you've seen one-to-one programs with iPads and Chromebooks and all this. Great. So we've freed up the lab. Now we have kind of an odd thing happening where I don't want to be totally pessimistic, because I love the maker movement. And I'm a big fan of making, and I'm a Maker Faire producer, and I've done a lot with that. But we're now bringing kids back to the Maker Lab, and treating it like an initiative, which, a lot of people are piloting stuff like that, and that's okay. But now we want to start taking that maker lab and do the same thing we did with our computer labs and start bringing it into the classroom and see these skills being used every day and not just once a week. So we have this pattern, and maybe it's time to get out of, and for me anyway, it's time to get out of the pilot phase for the maker movement, and it's time to move that into the classroom.
Dan, how do you see that playing out? I mean, it's one thing to look 20 years ago and say, well, now you can't really have a computer lab. Every student needs to have a device, right? Everybody has to have something. So they're look, as much as I have nostalgia for Oregon Trail too, right? You can't say we're going to go to the computer lab, but do you really see in 5-10 years everybody sitting there with a bunch of little bits at their desk?
I don't know that. I mean, I'm sure that there are going to be, if you're doing industrial making, there's going to be a reason to have a space where you have a huge laser cutter in your school, and that's okay. Maybe just the way that we treat those materials and the opportunity to use those is not like, oh, I only get like 45 minutes once a week to go and try to use this laser cutter or whatever. Maybe we schedule things differently. We look at ways to make sure that students have easier access to those. So if they have an idea, they can act on it fast. And the other thing too is, now we have had, Chromebooks seem to be really taking off, right? I think at one point Chromebooks seem to be doing a little bit better than the iPads over the last year or so. And the one thing to just think about that is that I think Google Apps and a lot of what you get on a Chromebook is kind of I want to say leveled off,
Right.
where it's time to start thinking about what you can do beyond Google Docs and Google Sheets and Google Slides, and to start to think, what do we do now? Well, let's program.
Right.
Let's hack it away and build something that way.
Well, you can certainly see that there's a direction going there. I mean, it was last year or 2 years ago, Apple came out with Swift, and even this year on the Apple Distinguished Educator applications, it's, where's your iBooks, where's your iTunes U, but hey, where's your Swift stuff that you're using? And even, was it yesterday, Apple just redid their iPad lineup, and their lowest iPad is now $349, somewhere in there, which is, it's a decent-sized Chromebook that you can get for the same exact price. So it is interesting to see where education is going to lead and follow, because you're right, over the last couple of years, Chromebooks have kind of dominated tablets.
Yeah, no, and it's definitely a competitive space, no doubt about it. And competition is good, if we're driving prices down, if you're just giving more access to more opportunity to more students. So that's a good thing.
We're here today talking to Dan Rezac from Tynker.com. Of course, you can check them out on Twitter over at GoTynker. That's GoTynker.com. And Dan, I know you wanted to do some demos. What kind of things did you want to share with us today? Because I am really excited to learn a little bit more about how this works.
Yeah, sure. Well, one of the things I get really excited about is integrating Tynker into the core classes. And so I like to always highlight the ways that Tynker plants the seeds of STEM at very early ages. So this is our Tynker workshop, what you see here, and this is kind of our standard development environment for kids. But we also have a puzzle environment that you've probably seen if you've done an hour of code. And this is, it kind of looks like this, and this is a conditional loop exercise. So these are two examples just to kind of throw you in real quick. Hopefully there's not a whole lot of audio there. So I'll start with this younger exercise because it's kind of like kindergarten, first grade level. And one of the things I like to highlight when I show people this, as this lesson is designed for you to, you have to make the spaceship reach the power cell. And this is about a conditional loop, basically. And so as we put this together, I was actually talking with a group of teachers a couple of weeks ago, and I was like, hey, so as I'm doing this, this if-then statement, and I'm not a math teacher, so I asked this teacher, this group of teachers, I'm like, so what is this if-then statement? Talk to me about that. What is that represented in math? What is that? And one of the math teachers was like, well, that's geometry, and it's like it's a proof statement. And I was like, well, we're doing this in what, first grade, kindergarten. Is that okay? Like, is there something wrong with us planting these seeds of math at that early an age? And of course, nobody says no. And so I just, it's one of the ways, many ways that we're planting seeds at a very early age of math concepts that they may not know that this is geometry, and that's okay. And they may not know that this is a high level math concept, but when they get into, 7th and 8th grade and they start doing this, it's going to click for them. One of the other little fun things too is that we just added this option on some of our puzzles, where you can now toggle between Tynker, JavaScript, and Python. Do you see that?
That looks really, really neat, actually.
So we're always trying to make the connection between, these are universal Tynker blocks, but they also translate to JavaScript. They translate to Python. And a young, a first grader is not going to know what that means. And that's okay. What we've done is we've ignited inquiry. Kids are going to ask questions. They're going to start saying, hey, what does this do? What I don't understand what JavaScript is. And that's exactly what you want them to do. Like, when you have them asking those kind of questions, you've got them, right? And so I can actually just play through that, and you can watch him reach his power cell. But this is just kind of like the fun, playful nature of our earlier puzzles. They're designed to be self-guided. So after a student reaches the end of one level, they get some stars, and they're asked to go on to the next one. And the reason that's cool is because it changes the dynamic in the classroom. If you've ever taught with Scratch, or you've taught with some of these other programs, I know, because I've had to force feed, computer science information to students, and that's really hard. That's a lot of work. This doesn't do that. This basically ignites them. They kind of work through things, and they start learning the terminology themselves. And if they have a question, they're going to raise their hand, and that's what you want, because now you're going to be working on things authentically with them. One of the other there's a couple little other examples, but one of the other ones I like to show is this is one of our animation lessons. And I think if you're familiar with Scratch or something like that, you're probably familiar with, you have to be familiar with XY coordinate if you're going to use, if you're going to use Tynker. And so I like to just kind of point that out, because, you've got very young kids who are going to start asking questions like, what do these numbers mean? What is this line? And what is this X? I don't understand. And I've been there, because I've been in class where they do this very thing. And that is inquiry at its best. You want them to ask you, like, how often do you ever hear kids saying, can you please teach me and tell me about XY coordinates? I really want to know this. So it's just a really, just one of those simple embedded examples of how we're planting those seeds. And then, of course, if you want things to work, you're going to want, like, let's say in this case, you want the fish to move. Your students are going to start asking you questions about angles and degrees, some basic things that we consider basic math, but a third grader is going to, not going to think that. And that's inquiry right there. That's what you want. The other one of the fun little things I like to point out is just, we have these cool physics blocks, and we have this is a game called some sort of, I don't remember the name of this game, but it's it kind of is reminiscent of an Angry Birds type of game. And if you look in our blocks, as you start looking up all these different blocks, you're going to find the physics blocks. And again, here's another opportunity. I was working with a group a couple months ago, and they were trying to create the bottle flip game. Are you familiar with the bottle flip game?
I've seen 7th graders love this thing, and I've seen bottles explode in hallways. So yeah, I like the bottle flip game.
If you just Google it, you'll see a lot of video. There's an original video. In fact, I think I talked with somebody who was the original school where that video came from. But some kids have tried recreating the bottle flip game in Tynker. And to do that, you really should use the physics blocks. And I'm just going to use this area just as an example, but when you start getting kids moving in that direction and saying, okay, I want my game to work this way, and I want things to fall naturally, and I want this, you're going to have to turn them on to their physics blocks. And the reason that's important is because now they're going to do the same thing they did when they were asking you about X, Y coordinates, when they're asking you about conditional loops. They're going to start asking you, what is force? What is impulse? What is torque? These are terms I'm not familiar with, but that is inquiry. And kids are super motivated when they're using Tynker because they want to make stuff work, right? They want to, whether it's a game, it doesn't have to be a game. This is an example of a presentation. And it's a self-playing presentation. One of my students did a few months ago about Frederick Douglass. So another example, this is not just about game making. It's about movie making. It's about storytelling. It's about, it's about slideshows, timelines.
And Dan, is all of this available on your desktop, Chromebooks? Like what platforms are optimal for using Tynker?
Well, all of the curriculum stuff, if you want to dive into the curriculum, kind of like I am now, that's going to be on a desktop computer. So Chromebooks, MacBook Airs, whatever you need there, but definitely, I would recommend using Chrome. But Chromebooks are great. Your iPads, if you want to start doing stuff like flying your drones and connecting to your maker, robots and stuff like that, like your Lego We-Dos, which we now connect to, you're going to use the iPad app for that. I'm just thumbing through our STEM lessons here because there's literally hundreds of opportunities for you, whether, as a classroom teacher or a technology, coordinator, coach, integrator person, to have that conversation with your teachers. When your science teacher is doing stuff about the brain, or, I'm just thumbing through these, but there's so many when it comes to STEM. These are actually what really got me excited about Tynker in the first place when I started looking at these STEM lessons. But here, let me stop sharing my screen here for a moment. Yeah, when I first started looking through the entire Tynker curriculum is when it all started clicking for me, because I started seeing that we had this huge array of STEM lessons, and now we've got like over a couple hundred. So if you had a social studies teacher who was doing a lesson about ancient civilizations, well, dang, there we've got a template you can use in that lesson ready to go for you, and just name the the unit, and we've got something. And that was really key for me. Here's a drone. So if you're using the iPad app, you're going to want to get a parrot drone, and we connect with all the parrot drones and Sphero and the Lego We-Dos through the iPad app. So
that's pretty impressive. Dan, I want to say so much thank you for sharing all that with us. For anybody that's out there looking to figure out where they can go or what they can do to learn more about the great things that are happening at Tynker, one more time, talk to us about that professional development opportunity.
Yeah, go to tynker.com/Blue Ribbon. And right now, applications are open until April 20th. So you have a little bit of time. But if you go to another thing you should check out, because it's really awesome. Part of the whole Blue Ribbon mission is to make computer science a reality for everyone. I mean, that's it. And the theme behind this is to go beyond an hour of code. I want to start seeing these things happen every day. But in order to do that, we kind of have to make this more than just an hour, more than just a week. It's got to be an everyday activity. So if you go to search the hashtag beyond 1 hour, just in the last day, you can take a look at that hashtag, and people are posting videos of what they think an hour, going beyond an hour should be. So there's a lot of fun stuff there. So check out Beyond 1 Hour.
That certainly, I have it pulled up here, and we'll certainly put a note on that on the show notes. Talking again to Dan Rezac from Tynker, tynker.com. You can, of course, find them on Twitter at GoTynker. Dan, I'll give you the last word here. What advice would you want to leave anybody on, how do you jump in? Where do you start? What would you tell anybody out there?
Well, absolutely. If you're starting with, if you want to make if you feel the urgency, first of all, like I do, because we got to get everybody prepared for the present. Just go to Tynker.com/join. If you haven't joined, go ahead and join and start playing around. Have some fun. There's so many activities there for you to just share with your students. But then obviously just go there and play around, add some students, and Tynker.com/join is the place you're going to want to go. And of course, you can go to Hour of Code too. There's like a million things there too. But this will really get you into the heart of what Tynker's all about.
Certainly check it out. Dan, I want to say thank you so much for coming on, and please come back on the show to share more about the great stuff that's happening with Tynker and in your neighborhood.
Thanks, Jeff. Thanks so much for having me. I appreciate it.
And again, thank you for taking the time to make TeacherCast part of your professional development. We hope you've enjoyed this show. And if you have an idea for your own show, please let us know. We love it when you reach out to us on Twitter at TeacherCast. Leave us a voicemail over at teachercast.net/voicemail. Email us at feedback@teachercast.net. And of course, take a moment and subscribe to our audio and our video shows over at teachercast.net/audio and teachercast.net/video. On behalf of everybody here in the TeacherCast Educational Broadcasting Network, my name is Jeff Bradbury, reminding you to keep up the great work in your classrooms and continue sharing your passions with your students.